So, cameraman Rima, today's topic is Graviton model for dark gravity. Okay, cameraman, and antimatter. Okay. Suppose
Woody?
suppose we have an space.
हाँ
We have a
ठीक है
space. No.
हम्म
Now, how will you differentiate this space? How will you differentiate this space? If this space doesn't have any matter, okay, mass, you cannot differentiate, but you can differentiate it this empty space if this space has energy. This space has energy. How energy? This is physical space. This is physical space. But how will you differentiate this space with energy? The simplest possible way energy can be represented in this space, so that this space can be differentiated, okay, is by a 2D sheet. By a 2D sheet. Okay, simple way. Flat 2D sheet. Flat 2D sheet. Okay, cameraman. And this flat 2D sheet is quantized, and this sheet energy is also fixed, energy is also quantized, and this sheet is known as Graviton sheet. What? Graviton sheet. Okay, cameraman? In deep space, this 2D sheet is flat. Okay? Flat. Now, but deep space may not be the simplest formulation like this. For deep space may not be the simplest formulation. Okay, deep space may have some complexity, may be complex than this imagination. Okay, that means in deep space, this flat sheet may have some internal vibrations, vibrations, but we ignore. And we, since everything is with respect to deep space, not this imagination. So deep space, we assume that it is flat. Okay, okay, cameraman. Now, next step of modeling is deep space may have many sheets. Nah, that means in deep space, one quantized sheet, flat, one graviton sheet 2D. Adjacent is second graviton sheets. These are quantized. These are quantized separately, so that space points are flexible. Sometimes graviton sheets may interact in this direction. Sometimes sheets may interact in just opposite direction, this direction, because of this quantized nature of sheet. But in any case, in deep space, these sheets are interacting. These sheets are interacting. Of course, they have individual quantization, but they are interacting. Interacting. That means in deep space, simple model suggests that one seed interacting with other seed, interacting with other seed. Now, there is some interaction, interaction. This type of interaction we will call it long range interaction. Okay, cameraman, long range interaction. We will use this long range interaction during development of antimatter. Okay, now first consider a simple 2D sheet. Ignore all these long range interaction, internal vibrations, ignore all this. Suppose sheet is flat. Sheet is flat. Now on this flat sheet, photon, that is light, travels on this flat sheet with a speed c. What light causes is that it converts these 2D graviton sheet into a 3D entity. What, cameraman? If these two sheets is represented by a single line, so when light passes, this 2D sheet changes into 3D projection. 3D projection, something like this. This sheets, one portion up, one portion down, up, down. Okay? Okay, cameraman? So, this 3D projection, when light passes from this 2D graviton sheet, this 3D projection, we call it what? Graviton particle. Graviton particle is nothing but it is 3D projection of two-dimensional graviton sheet. Okay? When light passes. When light passes. Suppose we have A and B and we have one sheet. We have one sheet and suppose light photon passes with the speed c. Then between A and B, what will happen? Sheets to this 2D sheet will take 3D projection. That is, sheet will be something like that. So between A and B, physical distance AB is same, but now one 2D sheet, graviton sheet, has been converted into 3D graviton particle. That means this space needs extra sheet. This space needs extra sheet which comes from the environment. And now second graviton particle can be accommodated. Equivalent, we can say that A and B, there is suppose one sheet. Then when light is passing with different frequencies, there may be n sheets. There may be n sheets. Okay, cameraman? Okay. When light, suppose this is one sheet, and light passes. Light passes. Then between A and B, what will be sheets? There will be n sheets. N sheets, equivalent. Now when light pass, that is leave this region, then number of sheets will be reverted back. Okay, one sheet. Okay, but now suppose light is passing between A and B reversibly. Cameraman, see here. Suppose light is passing A and B reversibly. Light is passing between A and B reversibly. Then again number of sheets will increase. Number of sheets from environments will be move inside. And when light passes, again from this region leave this region, this figure changes into this, and number of seats goes back to the environment. Na? This is the situation with mass. What is mass? Suppose this is mass. Na? This is mass. And is it associated with? It has gravity. It has gravity. Na? So what this means? Mass is nothing but reversible passing of light. Reversible passing of light. Reversible passing of
light.
Suppose this is deep space. Na? Deep space. Na? And suppose light passes. And suppose there are deep space, flat sheets are there. And now light passes. Light passes in a circular way. Okay? So average number of seeds, graviton seeds, average number of graviton seeds in this physical increase will increase. Number of seeds more number of seeds are accumulated. Na? Because they have been converted into particle. Similarly, this forms mass. This forms mass. But this extra seeds comes from environment. From environment, and light is passing, so seed form, seed will go on, seed flat, go on, na, reversible flow. So seeds will also be traveling outward. That means in effect, not light is constrained in this M, mass M. Seeds on an average number of seeds will increase not only here but surrounding region also. And this increased number of average number of seeds is represented like that. Na? Previously seeds were flat. Now seeds have been changed into graviton particles, so that number of seeds between any 2 points has been increased. And this zigzagness shows increase. Na? Of course, closer to mass, number of seeds are more, and this zigzagness decreases. That is, number of seeds decreases according to 1 by r square rule. Na? Okay?
Yes.
This is the effect of mass and gravity. Okay? Now, in deep space, cameraman, see here. In deep space, sheet is initially flat, and when light passes, then seeds are changed into this orientation. Na? Seeds are twisted, changed into 3D particles. Na? But in gravitational fields, this is deep space. So deep space, we have basic flat sheet. Light changes, increase the number of sheet. Okay? But in gravitational field, where light is passing reversibly, initial sheet is already changed into graviton particles. So in deep space, sheets are flat. In gravitational field, sheets have been, extra numbers of sheets have been, in deep space 1 sheet, now there are n sheets. Na? The initial point is that number of sheets have been increased due to gravity. Due to gravity. Okay, cameraman? Now, in deep space, on this flat surface, light passes and it's changed the sheet structure. Okay? But in gravitational field, this surface is already zigzag. So now light will pass, light will superimpose on this. Light will superimpose on this zigzag sheets. Na? This zigzag sheets as extra superposition. As extra superposition. Na? Okay, cameraman? Now, this is the situation. Now we consider a flat sheet. Suppose, cameraman, 2 flat sheets. 2 flat sheets. Okay? In 2D flat sheets. In deep space. So, in terms of lines, this can be represented by this. Okay. Now one photon P1 travels in this sheet, in this direction. Other photon P2 travel in this direction. Now, so how sheets will change? Sheets will change like that. Now, this is one sheet. This is two sheets. Now these vibrations will collide. These vibrations will collide. Now see, if this is the basic sheet level, suppose this is basic sheet level. Light changes upward, downward, upward, downward. Now these vibrations move with the speed of light. This is photon P1, and this is second basic level of basic sheet, and light changes vibrations as vibrations, changing the sheet into graviton particle, GP. Okay, cameraman. Now these two vibrations, see here, cameraman.
यही देख रहे हैं, यही.
Rima, these two vibrations now collide.
आपस में वो हो गए.
Collide कर रहे हैं, ठीक है ना? Before collision, suppose above base level, this is positive, this is negative, this is positive, this is negative, this is positive, negative, positive, negative. But these positive negatives are not fixed because after some time, since these vibrations are moving with the speed of light, see this same figure, this same between these 2 points. Now after some time there will be negative vibration. Okay. And where there is negative, it will be changed into positive. So vibration is moving. Vibration is moving. But when these vibrations, that is charge, that is between any 2 point, fixed point in space, vibration change sign, positive changing into negative, negative changing into positive. That is between any 2 point, there is no net charge. There is no
net charge.
Okay. But when these photons collide, these vibrations closes. These vibrations close. Okay. Because this vibration is restricted by this vibration is restricted by this vibration. Then overall vibrations are closed. This figure closes. This also closes. Okay. Now, since situation is symmetric, for example, negative closes. And here what will be closed? Positive close. Negative, positive, negative, positive. When vibrations close, then between any 2 points, then vibrations between 1 point, positive negative was converting, there was no charge. But when vibrations close, these vibrations may vibrate. Closing vibrations may move. Suppose this, positive here, negative here, positive, negative. And at the next moment, it will be shifted here. It will be shifted here. Okay, cameraman? Now these closing vibrations are vibrating vibrations are what we can say massless negative particles. This is massless. This is definition of charge. This is charge. we can say charge is moving. Charge is moving or vibrating. What you want to say? This is negative charge. This is positive charge. All these things. But there is a problem with this model. There is problem with, since these two positive and negative vibrations are symmetrical, exactly symmetrical. Symmetry is there. No? So if sheet is basically straight, flat, then these charges will be alike. These charges will be alike. This charge, although we have shown positive or negative, but these charges are same. These charges are same. Okay? That means to create two charges of different nature, positive or negative, we need what, cameraman? We need not a flat sheet. We need not flat sheet. We have to start with something like curved sheet. Something like curved sheet. This sheet is not flat. Nah. We should start with a curved sheet. Nah. Okay. So in deep space, now the role of long range interaction can be recognized. In deep space, sheet is flat. Sheet is
flat.
But they are interacting. They are interacting. Nah. These sheets are interacting. Interaction means these sheets during interaction, these sheets curves. These individual sheets during long range interactions in deep space, sheet is curved. Sheet is curved. Okay, curved. Okay. Okay. It is the level of universe. Universe. Suppose in this region of universe, curvature is, in this region of space, curvature is this. Maybe in different region of space, curvature may be different of graviton sheets. These sheets, it includes a smaller number of original sheets. Nah? But they are also curved. They are also curved. But overall curvature is different. So the number of sheets between these two physical distances are less, and where curvature is more, there are more number of sheets. Nah? But individual sheets are also curved. Individual sheets are curved. If two individual sheets, for example, one sheet and other sheet, they are curved. Okay. Now we pass two photons P1 and P2 as vibration on this curved surface. Then one vibration will be above curvature and other vibration in just opposite curvature. Okay. That is, this is positive curvature. Nah? Okay. And this is negative curvature. Now these two curvatures will not be symmetrical. Okay. Positive, negative. Positive, negative. Positive, negative. Positive, negative. Sub negative. Nah? Something like that. Nah? That is, vibrations can be represented by something like that. Nah? So these two sides are not same. Of course, in flat sheet, these two sides are same. So whether up vibration or down vibration, they are symmetric. They are symmetric. But now these positive and negative vibrations, positive and negative vibrations are not symmetric. Now are not symmetric. Now these two, similar to these vibrations, when these two vibrations, when vibrations on these two seats, na, okay cameraman, collide as shown previously, and vibrations are closed, then we have two options. Suppose this is one sheet curved, this is other sheet. One vibration of vibrations of light moving in direction. This is other vibration. Now positive, negative, na? Positive, negative. But these are not symmetric. These are not symmetric. And these sheets are in interaction, long range interaction. That's why they are curved. Okay? Now what will happen? Due to long range interaction, there will be two options. Whether all these positive vibrations merge. All these positive vibrations merge. So that these two sheets, due to long range interaction, they are in vibration. Curvature is one vibration, but because of collision, they may these two vibrations with their positive ends may merge. In that case, we will find that sheets will orientate like that, and all positive vibrations will be in center. Come to one point. And negative vibrations will be just outside. Okay? Just outside. This is one figure. This is, we call it matter. What we call it? Matter. At the same time, when these vibrations collide on this curved sheet, and curvature is due to long range interaction, these sheets may further curved, that is fold, not in this direction, but in this direction. As a whole, they fold in this direction. In that case, what will happen? Negative vibrations will be at the center. Merge. Negative vibrations will be at center. Okay? Negative vibrations will be at center. And positive vibrations will be at outside. Will be outside. Okay? Okay, cameraman? Okay.
Yes.
So this is antimatter. This is antimatter. They are mirror images because of long range interactions, whether sheets come closer in this fashion, or they will produce matter, or in just opposite fashion, so that negative vibrations are at center. Negative vibrations are at center, and outside it is positive. So matter, antimatter are formed. Okay? Cameraman, now what we see, we need what we see on flat sheet, we need symmetrical vibration. Okay? We need symmetrical vibration. But these flat sheets actually have long range interaction. So that these sets are not actually purely flat. they have some curvature interacting with others. Na? Okay? Now, these curved surfaces, when we give symmetrical vibrations, they become unsymmetrical. They become unsymmetrical. Na? Now, when these vibrations collide, and because of long range interaction of seeds, we will get either matter or antimatter. Okay? So this is how antimatter is formed. Na? In gravitational field, this is deep space. Deep space, suppose between A and B, one seed. And because of mass and gravity, where gravity is there in space, because of some mass m, between same A and B, we may equally have, because seeds may now be zigzag, but still basic structure will be flat. So there will be n number of seeds in a high gravitational field. Okay? But as in deep space, these two seeds have long range interaction. In gravitational field also, these sheets may have long range interaction. They may not be flat. They may not be flat. In fact, individual seeds may be curved between A and B. Of course, there is only one curvature. Here may be three curvatures. Na? This is one curvature. Here may be three curvatures. Okay? And on this curved surfaces, when we superimpose symmetrical vibration, these vibrations now become unsymmetrical. And when these vibrations collide, then because of large range interaction, whether these sheets close overall due to long range interaction like this, we got what? Matter. Okay? Or we can got what? Antimatter. When these curved sheets close in just opposite way. Na? Okay? We got what? Antimatter. Na? Okay, cameraman? So this is how we get charges and matter, antimatter. Na? Like that. Now, long range interaction means what? As we have shown, as we have said, at the level of universe, because of long range interaction between these quantized seeds, overall curvature may be different, although they have individual flat seeds. They are interacting. Overall curvature may be different. Na? Overall curvature may be different. Na? That means if these distances are same, AB means same distances. AB same distances. AB same distances. But curvature is overall different. Overall curvature is different. That means number of seeds between A and B in this part of universe U1 will be different compared to this part of universe U2 compared to this part of universe U3. Okay? Closer to our environment where earth is, moon is, na? Separate bodies are there. Na? Suppose this is sun, na? We have earth, na? All these. So we have a different overall curvature of graviton seeds. Na? Graviton seed different overall curvature. But in another region, there may be more curvature. Number of graviton seeds may be more due to long range interaction between sheets. Okay? So basic formula of gravity will be same. Basic formula of gravity will be same. Gravitational force between two masses will be given by same. G into m1 into m2 upon r square. Na? Formula will be same in both universe, both part of universe, U1 or U2. Na? Masses are m1, m2. Na, same masses. At same distance between these two masses. Between this space and this space. Formula is same. But overall value will be different. Here gravitational constant will have different value in this part of universe. Here it has different value in this part of universe. Na? This is the reason for dark gravity. Dark
Gravity.
or you may call extra gravity.
Thank you.
Extra gravity. Now we stop here, cameraman, for today.
Thank you.
Look,
Thank you.
Rima, thank you.
Thank you. Thank you.
Show your face first, cameraman.
Thank you.
So, Rakesh Srivastav sir is watching, and thank you sir, you are watching. And so with this Graviton model and with this representation of energy and including in this by this Graviton model and including long range interaction between these quantized graviton sheets, overall average curvature of these these gravitational space in our part of space, Earth, Sun, and in some in deep other galaxies or in constellations, there may be different overall curvature of the space or graviton sheets, so that gravitational constants may not be same. Although fundamental is same, that because of interaction between these graviton sheets, individual quantized graviton sheets will not be flat, but individual sheets will be curved. Okay, and on this curved sheet, when light passes as a photon, symmetrical vibrations change into unsymmetrical vibrations, and when two photons collide, they give positive and negative charges. Okay, as vibrations are closed, and because of same long range interaction between the sheets, these photons are their unsymmetrical unsymmetrical vibrations. When collide, there may be two possibilities, that individual sheets may, so that curved individual sheets overall, individual sheets may close in such a way, whether clockwise or anti-clockwise, something like that. You can say that curved sheets are closing so that outer parts come closer one way, or due to long range interaction inner parts come closer. So because of that, positive vibrations may come closer, form a nucleus, and negative vibrations forms the electron field. Now in just opposite direction, that is when internal parts closes, then all negative charges come at one place, that is negative nucleus, and outer parts make positron field. So this is the way how long range interaction of these individual graviton sheets creates matter and antimatter. So this graviton model explains formation of matter and antimatter, and this graviton sheet model with long range interaction also explains how gravitational constant may be different in our part of space in this universe, and may be different in some other part of universe. It depends on how overall curvature of these graviton sheets on long range is actually differs. No, but the basic mechanism of formation of matter and antimatter is same across the whole universe. Of course, for the calculation of gravity, overall curvature signifies the number of graviton sheets, and that's way gravitational constants that dictates gravitational constant. Of course, formula and all these things will be same, but gravitational constants value of z may not be same across our whole universe. So Rakesh Srivastava sir, thank you for watching this, and other persons are also watching, not only may be watching, not only in northern India but also in southern India and across the globe. That's why I am trying to make these episodes in English so that I can reach to wider students, wider professors, wider audiences in English. Of course, English is not very good. No, my English is not very good. It is fluctuating, but science, for science students, this fluctuation should not create any problem. And basic idea what I want to propagate, or we can say, since you are also the audience and part of and seeing this video, so you are equally part of this idea. So we may propagate this idea across the globe. Of course, idea may not be 100% correct, may be 100% wrong, but we are making effort with you, which includes I and you and all of you, and more good theories, more refined theories, more generic theories may be developed on these lines or may not be developed, but more than success, we should recognize the level of effort we are making in the propagation, in the understanding, for the understanding of science, better understanding of science at the global level, which is my aim, and since audiences are also great audiences are, and patient audiences are also seeing, so with me they are also contributing to this great effort for the progress of science and technology across the globe, because progress of science and technology can only make our world better, sustainable, and millions of peoples are in dire poverty, and we have energy resource crisis. All of this can only be solved by good physics. Jai Hind, Jai Bharat, Jai Visv. Thank you, sir. Thank you, Rakesh sir. Thank you.